Myself, Dr. Prashant Kumar Bolton, Professor, Department of Mechanical Engineering, GIS College of Engineering. My subject topics: Advanced Welding Technology, ME 703A, lecture number 19, Welding of Plastics, Ceramics, and Composites. Welding of plastics, ceramics, and composite. So far, we have discussed about the welding of metals. So today we will discuss about the plastics, ceramics, and composites. Welding, how welding is being done. Today's content, lecture content is introduction, classification of plastic welding rod, hot sealing, hot plate welding, hot gas welding, ultrasonic welding, friction welding, laser welding, welding process for composite materials. Introduction. Mechanical fasteners, adhesives, and welding processes can all be employed to form joints between engineering plastics. Mechanical fasteners can join two components quickly, but they do not provide leak-tight joint, and the localized stress may cause them to pull free of the polymeric material. Adhesives can provide good properties and fully sound joints, but they are difficult to handle and slow to cure. Also, joint preparations and surface cleanliness need to be given importance in adhesive bonding. Welding can be used to produce bonded joints with mechanical properties that approach those of parent materials. Plastic welding is confined to thermoplastic polymer because these materials cannot be softened by heat. Thermosetting polymers, once hardened, cannot be softened again on heating. The heat required for welding thermoplastic polymers is less than that required for metals. Plastic welding processes can be divided into two groups. One is processing involved mechanical movement, ultrasonic welding, friction welding, vibration welding, and the process involved external heating, hot plate welding, hot gas welding, and resistive and implant welding. These are the structure how the welding plastic joinings are there. There are three. One is mechanical joining, screw, snap fit, press fit, etc. Adhesive bonding, cross linking, solvent, hot melt, and welding. Third is welding, ultrasonic, vibration, and heated tools. Classification of plastic welding. Welding processes are categorized by the heating method that is used. Two general categories are external heating, internal heating. External heating, it relies on convection and conduction to heat the weld surface. Hot tool, hot gas, extrusion, implant induction, implant resistance welding. Internal heating, it relies on conversion of mechanical energy into heat through surface friction. Further divided into internal mechanical, internal electromagnetic heating, that is ultrasonic heating, friction, laser, RF welding. Welding rod. A plastic welding rod, also known as a thermoplastic welding rod, is a rod with circular or triangular cross-section used to bind two pieces of plastic together. They are available in the wide range of colors to match the base material's color. Spool plastic welding rod is known as spline. Heat sealing. Heat sealing is the process of sealing one thermoplastic to another similar thermoplastic using heat and pressure. Direct contact method of heat sealing utilizes a constantly heated die or sealing bar to apply heat to a specific contact area or path to seal or weld the thermoplastic together. Heat sealing is used for many applications, including heat seal connectors, thermally activated adhesives, and film or foil sealing. High temperature hot plate welding. Tool is not coated with release agent. Tool is heated to 300 degrees centigrade to 400 degrees centigrade. Once the part is disengaged from the tool, any residual material is either oxidized away or mechanically removed. Non-contact hot plate welding. The part to be welded are brought near to the tool, that is 1 to 3 millimeter, and convection and radiation heating from the tool hits the welding surfaces. In this figure, the holding fixture is there, and this is the workpiece part to be joined, and the heating platen seals this seal stop and melt stop. This is a part, and this is a part are held and aligned holding fixtures. Holding pattern is inserted. This is the holding pattern is inserted. And third is part are placed against the platen to melt edges. These are the part are placed. Fitting platen is withdrawn. This is already joined. Part are compressed, so edges fused together in the plastic rod. This is holding fixture are spared heating, so already it is joined together. It is released and it is to be removed. Application of hot plate welding. Polyethylene P pipe welding for gas line installation. Fuel tank assemblies for the automobile industries. Limitations. One major limitation to hot plate welding is cycle time. A typical cycle time is 30 seconds to 0 seconds, and larger with the larger part. Larger with larger part, it can be as long as 30 minutes. Hot gas welding. This is similar to oxyacetylene welding of metals. The only difference is that the open flame of oxyacetylene welding is replaced by a stream of hot gas, compressed air, nitrogen, hydrogen, oxygen, or carbon dioxide heated by an electric coil as it passes through a welding gun. The process invented in the mid of 20th century uses a stream of heated gas, usually air, to heat and melt both the thermoplastic substrate material and the thermoplastic welding rod. To ensure welding takes place, adequate temperature and pressure must be applied to the rod, along with the use of the correct welding speed and gun position. These are the welding being done. The hot gases are being given, the pressure is given, so it is being done, joint is being done. Application of hot gas welding. It is used for fabricate pipelines, pond liner, and a wide variety of vessels used to join broken plastic easily. Advantages: easy to use, thermoplastic can be welded easily. Limitations: slow manual process cannot be used in mass production. Ultrasonic welding. This method uses mechanical vibration to form the joint. Vibration of high frequency. The part to be assembled are held together under pressure between the oscillating horn and immobile, immobile anvil and are subject to ultrasonic vibrations of frequency 20 to 40 kilohertz at right angle to the contact area. Alternatively, high frequency stresses generate heat at joint interface to produce good quality weld. Ultrasonic welding is divided into two major groups: near field, far field. Near field is this distance between the horn and the welding interface less than 6 millimeter. And far field, the distance between the horn and the weld interface is greater than 6 millimeter. This is a horn, sonotode, and this is a horn is there. So advantage in mass production because the welding time is comparatively short, applicable for both amorphous and semi-crystalline thermoplastic, used to bond dissimilar materials. Limitations: horn size is limited to design constraints. The process and tool must be adapted to materials to be welded. Applications: food packaging, computer components, challenging and critical applications is the standard disposable butane lighter. This is the figure ultrasonic welding, pneumatic pistons, transducers. This is converter, booster, sonotode, horn, and this is the material. This is the joining process, joining, and this is the machine, practical machines where the welding is performed. Friction welding. The friction welding of thermoplastic, also called spin welding, is based on the same principle as the employed for welding metals. In this process, one of the substrates is fixed while the other is rotated with the controlled angular velocity. That we have already discussed in the friction welding. When the parts are pressed together, frictional heat causes the polymer to melt and a weld is created on cooling. The major welding parameters include rotational speed, frictional pressure, force pressure, weld time, and burn-off length. There are four main vibrations: linear welding, the variations, linear welding, orbital welding, spin welding, angular welding, just like metal welding, friction welding. These are four types. The advantage of friction welding are high weld quality and simplicity and reproducibility of the process. Limitations: it is suitable only for applications in which at least one of the components is circular and requires no angular alignment. Applications: used to make thermoplastic manifolds for the automotive industries. This is the thermoplastic manifolds for automotive industries. This is laser welding. There are two modes of laser beam welding: surface welding through transmission infrared, welding, surface heating. The surfaces of the component to be joined are heated by direct IR or laser exposure for the sufficient length. This is the radiation, direct radiation, uh, length of time to produce a molten layer, usually from 2 to 10 seconds. Once the surface is fully melted, the IR laser tool is withdrawn from between the parts. The parts are forged together and the melt is allowed to solidify. Thorough transmission infrared welding, it is based on the concept of passing laser radiations through one of the components to be welded while having the second components absorb the light at the interface. This absorption results in heating or melting of the interface, allows the welding. Advantage of thorough, transmission infrared welding. It is a pre-assembled method, speed and flexibility. It can also weld unsupported internal wall with complex curvature if the optical properties. Weld quality is very good. This is the laser beam, just as you can see. Laser beam, transparent polymer and the absorbing polymer. Limitations of TTIR welding: one of the component must be really transparent to IR radiations. This is the moving directions and laser beam applications, brake fluid reservoirs, automotive marking lights. These are the joining of transparent polymer to non-transparent absorbing polymer. Welding process of composite materials, very important. Composite material, thermoset composite welding, unprocessed epoxy resin, thermoplastic film strong interface form, thermoplastic welding, strong interface form. This is the joining. Unprocessed epoxy resins. This is the thermoplastic welding. Thermoset composite welding. This is the applications. Thermoplastic welding, like the automobile industries and also industrial things, furniture, etc. being made, and thermoplastic epoxy resin. These are the joining. It is being used. Automobile, cars, cycles, etc. Mechanical joints, mechanical analysis, thermoplastic epoxy resin, and joining is very important. Mechanical resin, mechanical analysis, the big sizes, atomic force microscopy, and this is chemical analysis. This is a scanning electron microscopy. Just see the figure. Applications. Understanding the process, and it can be applied to aircraft applications in aerospace and aircraft. This is the toys. It can be applied, varieties of toys. And the broader application is car in the car, and then to the cycle. So wide applications on composite material in different area. References: E. Paul Diarmo and Black, Ronald A. Kosar, Material and Processing in Manufacturing, Pentisol, India. Robert A. Grimm, Welding Processes for Plastics, Advanced Material and Processes, Volume 147, 1995. Joining Plastic in Production, the Welding Institute, TWI. Gravel D.A. Benatar, Park J.B., Plastic Composite Welding Handbook, Answer Publishers, Munich. So, it's the end of this today's lecture. Thank you. Thank you for your questions. So, any question we'll discuss.